Okay, welcome back to Aero 206. This is the video for lesson 3. We're going to be starting work on project 2, which is a program to calculate the standard atmosphere using the 1976 model. So we're going to be making a standalone function that takes an altitude and returns temperature, pressure, density, and speed of sound. We're going to have it work for altitudes all the way up from sea level to the top of the mesopause. And we want it to have some air handling capability, and we also want it to have the capability to change unit systems between SI and English engineering units. Okay, so the first part of the project that we're working on today is making a standalone function using if-else statements and kind of building the air checking and altitude logic. Okay, so we need to first go over how to make a standalone function. Last time we had an inline function that was just down at the bottom of an M file in which we were doing other things. Now we're going to make a standalone function that's a completely different M file. Okay, so I'm going to click in my editor window here. I'm going to put it over on the right hand side by doing the window right arrow key, and then on the left I'll put my MATLAB window. And I'm going to create a new script here that's going to be my function. First thing I'm going to do is hit Control S to save this, and I'm going to do Atmos 206. I've already got my solution here and named that, so I'll just name this one Demo. Okay, so that's the name of my M file, and it also has to be the name of my function. Okay, the function has to match the name of the M file. So now at the top of my M file, I'm going to declare that this M file is a function. I'm going to declare the outputs from the function: pressure, temperature, density, and speed of sound. And now I have to say equals the function name. It has to match the file name. And now I have to list the inputs that I expect to be passed into the function. So H, altitude, is going to come in. I'm going to call it HN because I may end up using another variable internally for altitude depending on the unit conversions and stuff, so I just want to make the input altitude distinct, so I'll call it HN. And then we also need to have a variable coming in to specify the units, so we'll just call that units. Okay, so that declares my function. Now in here you need to put your whole header, and I'm going to skip over that for now because you know how to do that by now. And then all the way down at the bottom of the function, it is optional in a standalone function, but I can put the word end here to tell MATLAB this is the end of the function. Obviously the end of the file is kind of the end of the function because there's nothing left in the file for MATLAB to run in the function. But using an end statement is appropriate for defining the end of the function, and this is perhaps one of the criticisms that MATLAB receives sometimes is it allows for sloppy programming because I can put end here or I can not put end here, and you're just other programming languages won't tolerate that kind of sloppiness. But anyway, I'll put an end there for now. And to make my function at least runnable and testable, I'll just create some outputs here. I'll actually use zeros. Okay, so at least I can, so I just hit Control S, I saved it, and now I could run this function. Now it's giving me some warnings already because it's saying you're not using your input arguments H and units, but it should still be able to run. Anyway, if I do Atmos 206 demo, and I'll send it some inputs, and it doesn't even matter what they are right now, I'm getting a 0 back out. And the 0, actually, let me make this a little bit more descriptive. I'll do 1 for pressure, 2 for temperature, 3, and 4. So I'll save that, and now if I run this, I get a 1 out because I'm outputting multiple outputs from this function, but in my calling line over here, I didn't give it the ability to store multiple answers, so I'm really only getting the first answer out of the function, which is the answer for pressure. But if I call my function like this, and I say A, B, C, D, now I'll get 4 answers out, and it will store them in A, B, C, D. And in my workspace, you see I've got ABCD 1, 2, 3, 4, and I didn't suppress my function, so it also printed to the command window as well. Okay, I can do commas here, a comma B, CD, okay, and I get the same thing. And let's say, for example, I wanted to call it, but really all I needed was density, and that's pretty common. All I need for my Atmos program sometimes is density, and I don't want to deal with the rest of the outputs. I can just throw them away by putting the tilde sign there, and I'm only saving C, and I'll just call it row in this case, and that's just an easy way to get one output out of a function, because sometimes that's all you need. Okay, so that's the basic functionality of a standalone function. Let's go back to our Project 2 handout here for part 1. Okay, we created a standalone function that has 2 inputs, altitude and units, and 4 outputs. Okay, and we did that, and we made some test outputs, and we are running the function. Now we need to create a main driver script that calls the function and passes in stuff and gets stuff out. So I'm going to create another M file here, and I'm going to hit save on this, and we'll say Project 2 Part 1 Demo. And now this is my driver for my Atmos 206 demo function. And I'll just, instead of retyping this, I'm just going to go to my command history here. I'm going to grab one of these lines that I already used. I'm going to drop it in here. And now I've basically got my demo function that's able to call my demo driver that's able to call my demo function. Okay, so I showed how to run my function from the command line here. I can also, if I clear, and I should put this at the top of my driver program to clear CLC. I'm going to save that again. Just like I can run a function from the command line, I can also run the driver script, a primary M file from the command line. So I'm going to type in, I'm in the right folder, I see the M file here. I'm going to type in P2 underscore part 1, and I press tab and it auto-completed the name for me. And I'm just going to, it's not a function, so I'm not going to put any parentheses and input arguments here. I'm just going to run the file name. And it cleared, it CLC'd, and it ran my function inside, and it got ABCD out. Okay, so if you have a completely executable M file and you don't need to debug anything or run anything by line by line, you can always just type in the name of that M file if you're in that folder, and it will run it. So back to the Project 2 Atmos. We made a driver script. It's really basic right now. And we're not even really putting in realistic things right now. Okay, so we need to work on that. The first input is supposed to be a number. The second input needs to be something to specify the units. And we could use a number to specify the units, and then in our code we could say if input 2 equals 1, we know that's English units. If it equals a different number, we know it's SI units. Or we can use a string, which just makes a lot more sense for us to be able to track. And I'm going to use ENG as English and SI as SI. Okay, so now I've got a string going into my function as a second variable for units here, and then the number coming in the first one is going to be the altitude. Now we need to do some basic air checking in our function. This is always good stuff to do. We're just trying to make code a little bit more robust to user error, keeping in mind that if you're working on a group project, you may not be the only one using the M file, or if you come back to the M file or your function 6 months from now, you may not perfectly remember what you were doing. That's where the comments should come in handy, and that's where some good air checking will come in handy as well. Okay, so I'm going to come into my function here, and I'm going to create a section up top here just for air checking. And I like to do a few things in my function. The first thing I like to do is, just like MATLAB doesn't require all the inputs in a function call to be defined, we can create that same capability in our functions. So let's say that the user doesn't pass in units, and we can just assume then that they want English units. So I'm going to say if, I'm going to create an if statement here. And this is a special variable here, number of arguments in. If that equals 1, then that means the user has only sent one argument into the function, and in this case it's going to be the first argument, altitude, which is another reason to put altitude first. And in this case, I'm going to define that English units equals English engineering units, and then I'm going to end the if statement with an end. So this is a really robust way just to create capability to use the function a little bit easier. If you know you're defaulting to English engineering units, and you can make your function call shorter. You just have to be aware of what your function is doing, just like in any other MATLAB function as the capability for multiple inputs. If you don't put in those multiple inputs, it's probably assuming some defaults that are common the majority of the time. Okay. And I'm going to add a comment statement up here. So if the user only inputs one argument, assume English units. Okay. So that'll be first. So now for the rest of my error checking, I know for sure that I've got this variable units defined. Okay. But now I want to verify that the units are either English or SI. Okay. And I want to compare the input to some reference value. Okay, so let's say that I have a reference value called A, and it equals engineering. And now I have the reference value units equals engineering as well. Okay, now I want to compare these two things and find if it's true that they're equal or false that they're equal. So we're dealing with logical comparisons here, and the way that we do a logical comparison is with a double equals sign. If A equals units, or if units equals A, either way. In this case, I get a vector or an array of outputs, one for each character, because I've got 3 characters in the string array. So if I put in a capital E here in units, now the first position in this result from this logical comparison is going to be 0, because capital E doesn't equal a lowercase e. Okay. So we need a better way to do this, because we don't really care about each element in the array. We just care about the whole string altogether. And the way that we do that is using string compare. Okay, so I'm going to do help string compare, just like you can do, and you can read a little bit about how it's going to work. Basically, we're going to put in 2 strings, and it's going to give us a logical result for comparing those 2 strings. So I'm going to put in my reference, which is English, and my actual variable, which is units. And in this case, it is not the same, because my units is still a capital ENG, and my reference value here that I was comparing it to was lowercase ENG, so that's not going to work. Now if I did lowercase like that, now I get a 1 out, because this logical statement is true. These 2 things are equal to each other. Okay, but now let's go back and let's say, for the sake of argument, that we had a capital ENG. That's not really making my code idiot proof that this now is choking because I accidentally capitalized something. So I could add another function call embedded into this function call, and that's the nice thing about MATLAB. You can embed arrays within arrays within arrays, and function calls within function calls. And now I'm using the function lower, and lower is just going to force something to be lowercase. Okay, so now if I go back and do string compare English, and now I do lower units, now it is going to return a logical true value, because even though units has a capital letter in it, I'm forcing it to be lowercase, and I'm comparing that to my reference value. Okay. Or I could go back and I could use string compare I and do the same thing, and what string compare I is doing is it's just using a case insensitive form of string compare. So really you want to be using string compare I, and for your error checking in your function. Now if units equals something random, it's still going to return a logical false value. And that would be a good time to tell the user that you've picked the wrong units for this function. Okay, so now let's see what that looks like inside the actual function. So if I come in here, I'm going to create an if statement, and I'm going to say string compare I English to units. Okay, and now I want to do something if that's true, and then I want to end this if statement. Okay, so if units that the user passes in equal to English, I want to do something and then end. Well, actually, what I want is the reverse of that. If this is false, then I want to do something. I want to warn the user that they're not using the correct input. And so the way I can do that is I can reverse this value by putting a not in front of it. Okay, and let's see what that looks like over here. So let's say units equals ENG, and now my string compare I units equals ENG, so I get a true out of this, but now in front of this I'm going to put a not, and now I get the reverse of that, which is false. So this is what I want in my if statement. If this is not true, then do something. Okay, and another way of doing the not is just with the squiggly tilde, then it's the same as the not, and it returns a 0. So that's shorter to do, so that's normally what I do, is I just do a squiggly there. If this is not true, then I want to do something, and the thing that I want to do is, in this case, is I want to throw an error. So I'm going to use the error function, and I'm going to tell the user units must be English or SI. Okay, but obviously the units could be coming in as SI, and it would still throw this error because SI doesn't equal English. So what I want to do is I want to add another comparison in my if statement. If this is false, or if another statement is false. So I'm going to put a double vertical lines here for an OR operator, and then I'm going to say not string compare I SI units. Okay, so now if the units variable doesn't equal English or SI, then it's going to throw an error. And now let's test this out. Okay, so I've got Atmos 206 demo 1 in English, and it is throwing an error here. And it's throwing an error here because this statement is still returning false. So it's recognizing that one of these two things is false, so it's still returning the error. So what I actually need to do is say and here. If this is not equal to English and it's not equal to SI, then throw the error like that. So now if I rerun that, I get pressure back out. So, which means that the function is reaching down to line 23 here, which means it passed my error checking up here, which means I'm fine now. Let's try it with SI. SI is fine. Now let's try it with something random. And now it doesn't match either one of these, so it throws the error. So that's exactly how this error checking is supposed to work. There's another way I could do this, something a little bit more elegant, because I've got two comparisons here in my if statement. So let's say that I wanted to make my code a little bit more expandable in the future, and I was going to add other units or something like that. Well, I could create a variable called all units, and I'm going to make it contain all the units possible. And I'm using curly brackets here to define a cell array. We haven't gotten into cell arrays very much yet. But the first value in the cell array is going to be English, and the second value is going to be SI. And then I could come and say if, now I want to do a string compare I between all units, so every value in my cell array and the units variable. And if any of these are true, then I know I'm okay. So I'm going to put brackets around those, and then I'll use any of those. So you can see what any is doing by looking at the documentation for any. But now what I really care about is if any of them are false. So I'm going to negate all that by putting a not in front of it. So now if it doesn't match anything in my all units array here, then I'm going to throw the error Okay, and now I need to end this if statement. So it's a little bit more elegant because, and it's a little bit more expandable in the future, and I like this approach a little bit better. But either one is just fine. Okay, going back to the project. So we checked for the units. We need to check that the altitude is a number by using isNumeric, and we can think about other things we need to check for the altitude, like is it above 0? That'd be a good check. Is it below the top of the mesopause, etc., etc. So let's mess around with isNumeric first. So I'm just going to define HN here in my workspace just for working with it. If I do isNumeric HN, I get a logical 1 because it is a numeric. Okay, but if I do isNumeric on a units array like units, then I get a 0 because it's not a numeric value. It's a string array. So in this case, I want to do if isNumeric HN. Okay, and then I want to throw an error there and end this. So there'd be some error message here, and again, this is not what I want, because if it's numeric, it's fine. So I want the negation of this. So if it's false, so I'm going to put a not in front of it. So if it's not numeric, then I'm going to throw some error message. Okay. All right, and then finally, we need to check that the altitude's between 0 and the top of the mesopause, and we've already gone over the error command already. So now let's create another if statement here, and we're going to say if HN. So we're going to use different comparisons now. We've been using equals sign up here if the number of arguments equals 1. And now we're going to use other comparisons like less than 1. If HN is less than 0, error altitude must be greater than sea level. Okay. And now let's try to run this again. So I just double clicked on the command in the command history, and it ran it, and I spelled string compare I wrong. So all you have to do is read your error messages and then go and fix it. So let's try to run that again. Okay, now it's running. Now let's try to put in a negative altitude, and we get an error message back out, and the altitude must be greater than sea level. So, but we also want to throw an error message in this case, or if it's greater than the top of the mesosphere. So in this case, this is an appropriate place for the OR operator. If HN is greater than the top of the mesopause. What's the top of the mesopause? Let's go back to project 2. And we haven't even really scrolled down yet, but here's all of the equations that we're going to put in for the different bands of the atmosphere. And here's the mesopause. It's the highest band, and it ends at 298,556 feet. So 298,556 feet. So this is what we'll be coding up. And here's all the bands where the temperature profile changes, and because the temperature profile changes, we need to treat them differently. So we need to have distinct calculations for each band of the atmosphere, and that's what we'll be working through. And here's the equation for each one of those bands where the temperature is constant or where it's changing, and we'll ultimately be working towards these plots that you see here at the bottom of the handout. But for right now, all we need to do is compare the altitude to make sure it's within this acceptable range. And so now I'm going to change my error statement. Must be greater than sea level or less than the top of the mesopause. And now we'll go back to MATLAB and run this. And now if I put in an altitude of 300, okay, 300,000, it's greater than the top of the mesopause, so it's also throwing this error. The only thing I don't like about this is that I've hard-coded a number into an if statement here, and what is that number? There's no comment in this code saying what that number is. If I come back to this code 6 months from now, I'm going to be like 298.556. Where did that come from? And what does it mean? So it's just proper programming practice to create descriptive variable names and use them instead of hard coding in numbers and add comments where appropriate. So in this case, to solve this problem, I'll create a variable called top of the mesopause, and I'll say it's equal to this value here. And then I'll add an inline comment here, top of the mesopause feet, and then I'll use that variable name in my if statement. And now this code is much better written because I don't have that hard-coded number, and I've got a descriptive variable name and a comment for what the variable is doing. So I really need to go back and add comments for all of these error checkings to tell the reader what they're doing in plain English. Okay, just one other thing. In addition to error messages, we can add warning messages. So let's say, warning is less severe than an error message. Let's say that I only send in one argument, and I want to tell the user, like, hey, warning, we're going to default to English units. So a warning message isn't going to, stop the execution of code. It's just going to throw something to the user and let them know what's happening. So if I run my code here with an acceptable altitude, it's still running. Now if I take out the units, so I only send in one argument, okay, the function still returned a result for me. It's still sending out the first output from the function, which is pressure equal to 1. But it threw this warning here, and it's just letting me know you only sent in one argument, so I'm defaulting to English units. So warnings and error messages go really well together, depending on what you need to do in your function. Okay, so the other thing we need to do is to create if-else blocks for each band at altitude, okay, and add an fprintf statement that returns the input altitude and the name of the region. Okay, so we're going to, I'm going to leave that pressure temperature stuff down there. Okay, I'm going to make a new section in my code here, and I'm going to call it altitude bands or whatever. And now this is a good case for an if-else-if statement, because if I go look at my altitude bands, if I'm in this band here, I'm going to do something else. If I'm in this band, I'm going to do something else. If I'm in this band, etc., etc. And that's just naturally how this problem flows out as well. Okay, so I'm going to start off by saying if h in is greater than or equal to 0, which is the start of the troposphere, then and h in is less than 36089, then I'm in the troposphere. Okay. Now I'm going to continue the if statement with else if h in is greater than or equal to 36089. So right away you can see I've only created the possibility for one result if my altitude exactly equals 36089, and that's to be in this band here. Okay, if I had left an equal statement here, now I've got two places where this could be true, and I wouldn't want that. So else if hn is greater than this and hn is less than 65617, now I'm in the tropopause. Okay, and then I can just end it. Okay. Now the thing is, you can add as many else if statements as you need to in this code to define as many things as you need, and we're going to define one for each altitude band. Okay. I only did it once here for the tropopause, but you're going to have to go through and add it for the rest. Another thing about the if-else if structure is I can also just add an else statement at the end, and this is kind of the case where hn doesn't match anything else in the conditions stated. Okay. So this would be another good way to incorporate air checking, because if HN is in this band or in this band or in this band or in this band, etc., then that's all defined. Else, I could put an error message down here, error, HN altitude is not in an acceptable range. Okay. Really I don't need this else statement right now because I did some air checking early on to make sure it was not outside the limits of the altitude bands anyway. Now I could get rid of this actually and just use this air checking statement, but whichever way you want to do it is fine. So I'm just going to take out this else for now because I already did that one up there. So if, else if, now you need to add an fprintf statement here. Okay. And do what the project says to do for that, which was just print the name of the altitude region there. Okay, so you'll have to go through that and do that. You need to add that for all the altitude regions that we have in the handout and name them. And then you need to go through and test the code, test every altitude range, test, all of the air conditions that you created the possibility for, and see what happens. Okay. The only thing I don't like about this setup right here is that, again, we've ended up with hard-coded numbers in our if statements. All right, and there's a couple different ways around this, right? You could just define a bunch of variables where h1 equals 0, h2 equals 36089, h3 equals 65617. But as soon as you start doing this, you should recognize to yourself that, wait a minute, I'm typing in a sequence of values in separate variables, and now I'm just using up multiple variables in the workspace. It's going to clutter up the variables in the workspace. You're going to end up using this workspace a lot for complicated codes, and now you're just adding a bunch of unnecessary things in here. So this is not an elegant way to do it either. So how I did it was I created a HB, altitude bands, and I'm going to set it to an array. And I'm going to come in here and type in the start and stop values for everything in my array. Okay. And I'll just do the first couple ones here. So 0, 36089, 65617, and you can go on and on. And now, instead of hard coding in a number here, I'll say if hn is greater than or equal to hb, and I'll call the first value by putting parentheses 1 after hb. It's going to reference the first value of this array, 0. And if hn is less than altitude band, the second value, okay? So now I'm checking that hn is in between this number and this number right here. Okay, this is advantageous for a lot of reasons. I'm not putting in hard-coded numbers in my code, so that's good. It makes it easier to check for typos in HB because I'm going to have a string of numbers here going out, and I've got all my altitudes in one place, so I can just verify the numbers all in one place instead of scrolling through my code looking for the else if statements and then looking for the numbers that are in the code. Okay, so I'm going to fill in these values here too. Okay, so it's cleaner. It's more organized, keeps my workspace organized. It's easier to air check. Using an approach like this is just better all around. And the point is here, if you find yourself doing something a lot in MATLAB, like typing out h1 equals, h2 equals, h3 equals, you should probably step back because there's probably a better way to do it. And in this case, this is a much better way to do it. Okay, so that wraps up pretty much everything that we have to go over for part 1, and I'll see you in class.